In this video, we're going to talk about the first quadrant of the unit circle and how it's constructed from previous material that you've learned in geometry and or trigonometry. So we're going to start with special right triangles. There are two different types. One is a 30, 60, 90 triangle, and a 30, 60, 90 triangle has a pattern of three of the exact same ratios within it. Across from the 30, you have the set value. Some teachers call it x. I call it a because it's awkward to solve for x when this is already x. Across from the 60, you have a root 3, and across from the 90, you have 2a. So what happens there is you have a situation in which this is just in order of smallest to biggest in terms of this is the smallest angle, this is the smallest side, 1a. This is the second, so it's a root 3 or 1 point something, and then across from the 90, we have 2a. Similar situation with 45, 45, 90s, but because a 45, 45, 90 is also isosceles, we only have a and a root 2. So a common problem that students have is how to remember a root 2 versus a root 3. An easy way to remember it is this has three different values, so it's a root 3, and this has two different values, so it's a root 2. Not mathematical, but at least logical. So let's take a look at an example of how this may have looked in your geometry class. So in this example here, I have a 45, 45, 90 triangle. And what happens is I like to label it with the same ratios I have up here. So I just labeled across from the 45s, I labeled them both a, and then across from the 90, I label it a root 2. And so to figure this math problem out, you simply ask yourself, okay, where did they provide me with some numbers? So that they provided me with numbers here. So a is 6. So that means that x is 6, and that means that r is 6 root 2. All I did was substitute the fact that a is 6. If I look at a 30, 60, 90 triangle, I have a similar situation. I just have different common values. So again, I label. Across from the 30, that's a. Across from the 90, that's 2a. Across from the 60, that's a root 3. And then I look and I say, hey, where is there a value that actually has a math problem for me to solve? And that would be this one. And the reason that's the one is because, you know, we have an actual equation. We divide by 2. We get a is 7. Then I can go and substitute that into the other values. So a root 3 would become 7 root 3. And x equals a, so x would be 7. Okay, so let's take a look at the next piece that we need to look at, which is how does this deal with the unit circle? So the word unit means one. If you go to the grocery store and you were to buy a dozen of eggs for $2, that's how much 12 cost. And if you look at the tag, it'll say unit price, and it will tell you how much one egg is. And so that word unit is not a math word, it's just a universal word that means one of something. So if I take a look at a 30, 60, 90 triangle in which we apply the hypotenuse as 1, and that's the key to understanding what the unit circle means in terms of its definition. So in this 30, 60, 90 triangle, I have a hypotenuse of 1. I'm then going to label all the sides just like I did a second ago. So across from 30, I have a. Okay, across from 60, I have a root 3. Across from 90, I have 2a. And I ask myself, hey, where here do I have a math problem to solve? And that would be there. So I divide this by 2, and I get a as a half. Okay, and so that means if I label the rest of it, I didn't need to label this because it's already 1, but that value of a tells me that this is a half, the y is a half, and the x is a root 3, otherwise known as 1/2 root 3, but simplified in a way that looks more mathematical. 1/2 root 3 is root 3 over 2. So this x and y is also significant. Keep in mind that this is mirroring the y-axis, and this is mirroring the x-axis. That's going to come into play later with other aspects of this video. So for the 30, 60, 90 triangle, I can also have a 60, 30, 90 triangle or what have you. It's just the same triangle, but kind of upended. So the same situation, but now the hypotenuse is here. Instead of being there, it's over there. It's still the same hypotenuse. I've just upended the triangle. Again, I would label this now so that for my 30, I would have a. Across from 60, I have a root 3. And across from the hypotenuse, I have 2a equals 1. And again, here's the math problem to solve. So if I divide by 2, I get a half. Similarly, across from the 30, I would get the value of a half. I don't change this because this is 1, but 30 is a half. And 60 now provides 1/2 a root 3, otherwise known as root 3 over 2. Again, mirroring the y-axis, mirroring the x-axis. Very important for later. In the 45, 45, 90 triangle, my situation is similar, but my division is a little different. So I have A for both the sides of the 45, and then I have 1 for the hypotenuse, and that is equal to the value across from a 90, which in a 45, 45, 90 is A root 2. So I have a little bit more math to do here. I divide by root 2, so I get 1 over root 2. Then I have to rationalize. You can't have radicals on the bottom of fractions in mathematics. So we rationalize by multiplying by root 2 over root 2. That would simplify to root 2 over root 4, which reduced is root 2 over 2. And that is the value of the legs, and the hypotenuse stays 1. Again, mirroring y, mirroring x. Okay, there's one more thing we need to talk about before we put all this together, and that is tangents. Okay, so what is a tangent? A tangent previously was known as opposite over adjacent. But if you look at all these triangles, every one of them, the opposite is y and the adjacent is x. So thinking about that in terms of a little bit more algebraic connection to trigonometry, instead of saying opposite over adjacent, we're now going to say y over x. So if we look at the 30-degree triangle, the y is 1/2, the opposite is 1/2, the x is root 3 over 2, meaning the x part of it. So if I just do the math there, what I end up getting is y is 1/2, x is root 3 over 2. This would have to be reciprocated or flipped over, which you can see that I did here. The 2's would cancel. That would leave me with 1 over root 3, which again has to be rationalized. So tangent of 30, when you calculate it all out, is root 3 over 3. And that's the hardest one. The rest of them are actually pretty simple. So in a 45, 45, 90, they're both the same. Simple calculation. Y is root 2 over 2. X is root 2 over 2. That looks crazy, but that's the same thing over the same thing. That is 1. And for the 60-degree triangle, you have the same situation here, but it reversed, because remember, I upended it. So y is root 3 over 2, and x is 1/2. So that calculation is root 3 over 2 divided by 1/2. Same thing happens. This reciprocates or flips over. That's very convenient, because those just cancel out. Boom, root 3. No need to rationalize. So another way of thinking about tangent, you may recognize this in each of these. This y over x, y over x. That is the mathematical understanding of rise over run, otherwise known as slope. So if you go back and look at these triangles, it makes sense that the slope of this is 1. The slope of this is smaller than this, so this is root 3 over 3, and this is root 3, meaning it's steeper. All that is important once we put all this together. Okay, so the last thing on the unit circle, you can do the unit circle in degrees, but traditionally it's also done in something called a radian. So what is a radian? A radian is another way to understand the measurements around a circle. Okay, so the degree is a unit of angle measuring, defining the rotation of an angle, where the radian is the radius of a circle where it equals the subtended arc length. It's a little bit more technical. You don't have to worry about that too much, but you have to worry about this idea, is that when I rotate around a circle in mathematics, we actually go counterclockwise and count that positive. And when I do that, I end up at the very end with 360 degrees. It also is the same thing as 0. Keep that in mind, because I started here and I ended here, so it has a dual-natured identification. And that is also understood, if you go over this definition, if you go all the way around the arc that is the circle, then the subtended arc is 2 pi. So 360 is equal to 2 pi. And that will reduce to 180 over pi, which you can see that right here. Why is that significant? Well, if I use that logic, I mean, it makes perfect sense that over here is 180 degrees, which makes perfect sense. You know, half of the circle, 180 degrees is what we call a line in geometry, otherwise known as a linear angle. So that is equal to pi, okay? And so half of that is pi over 2, otherwise known as 90 degrees. You can see that 90-degree arc here. And then down here, if you take 180 and add 90, you get 270, which is, if you think about it, if this is 0, this is 0.5, this is 1, this is 1.5, otherwise known as 3 pi over 2. Little subnote, not significant in this video, that if you do go clockwise around a circle anytime in math, that is actually a negative rotation. Not significant in this video, but just it's there, so I'm going to mention it. So for the unit circle, we're going to do the conversion right here. This conversion we talked about is 360 over 2 pi. I could also reciprocate that for unit analysis purposes. They are the same conversion. One is degrees to radians, the other one is radian to degrees. So if I take a look at the conversion for these three things from the unit circle, the reason I picked pi over 180 degrees is so that these things would cancel. This is going to cancel out. And then I would simply reduce the fraction. 30 over 180 is 1/6, but there's a pi there, so it's 1/6 pi, or pi over 6. For the 45, again, want to cancel this out, so I do this. You get 45 over 180, which is 1/4. That's not immediately obvious, but it is if you think about the fact that 45 goes into 90 twice, so 45 would go into 184 times. And the last one is 60. You want to cancel out the degrees, so I do that. 60 over 180 is 1/3, or pi over 3. So now we are ready to put this all together and talk about the actual unit circle, quadrant 1. So quadrant 1 of the unit circle. First thing we have to understand is that the unit circle is actually a regular old circle with radius 1. And what we're looking at here is we're simply looking at quadrant 1 of this circle. And quadrant 1 is going to be super enlarged, and we're going to show it in detail. Notice that these triangles that we had in an earlier slide, I just simply imposed them in this small little quadrant, and I've made this much larger version to look at here. So big idea is it's a circle. Smaller idea is that we're going to look at quadrant 1, because each of these triangles is exactly things that we've talked about previously. So the first thing I think that's significant is to talk about the fact that this point is this point. And that point is 1, 0. So if I talk about it as a point, it's 1, 0. If I talk about it as a value in trigonometry, that value is, so in regular math, this is x and this is y. But in trigonometry, those are understood as cosine and sine. Now, why is that? Cosine is equal to, so cosine of theta is equal to adjacent over the hypotenuse. So if I think about adjacent over the hypotenuse, in all of these triangles here, the adjacent is the x-axis. I mean, here's theta. For each of these, the adjacent to theta is x. And the hypotenuse of all of these triangles is 1. So you end up getting x over 1. And that's how people can understand cosine as x in the world of trigonometry. Very important to remember that. So sine is considered y. So if I say sine of theta would be understood as opposite over hypotenuse. And if you look at all of these triangles, opposite is y. All of them have that correlation there. So again, the hypotenuse is still 1 on all these. That's the word unit in this concept. So that would be y over 1 or just y. So it is equally acceptable to call this 1, 0 from the fact that it's just a regular old circle, but it's also acceptable to call this sine of 0 is equal to, cosine of 0 is equal to 1, and sine of 0 is equal to 0. Okay, so the degree measures 0, the radian measures 0, the sine value is 0, the cosine value is 1, and the tangent would be 0 because that would be 0 over 1, otherwise known as 0. You can also think about it again as slope, and the slope of this line is 0. So the next point that we want to talk about is to look at the one up here. So this is also a point that maps to this point right here, and that point is the point 0, 1. So please keep in mind that this is 90 degrees, otherwise known as pi over 2. And when we talk about these points here, this first point is x, the second point is y, but it's equally acceptable to say cosine of 90 is equal to x, so cosine of 90 would be 0, and sine of 90 would be 1. The tangent is undefined because the tangent would be 1 over 0, and if you think about this again as a line, that is a vertical line. And there's a really convenient way to remember this from Algebra 1, a little mnemonic device, is called Hooyvux. Now, what Hooyvux does is Hooyvux gives us a way to remember the difference between horizontal and vertical line and their equation of their line and slope. So the horizontal line, this one right here, the one at 0, otherwise known in geometry as a linear angle, has a slope of 0, and if I was in an algebra class, the equation would be y. But a vertical line, which is this one right here, okay, has an undefined slope, and if I was in an algebra class, that would be an equation for x. All right, so now let's get into each of these triangles that we focused on today. So if we're taking a look at the first triangle, the 30, 60, 90 triangle here, what happens is we have a lot of information that we're now just going to correlate previously. So this is a 30-degree angle. We converted it previously to pi over 6. The point value, again, I'm going to go back to this thing. The point value is the values we got here. So notice that the x is root 3 over 2, the y is a half, and we did the tangent and found that it was root 3 over 3. So going back to that, we can see that the point is root 3 over 2, the x part of it, the y part is a half, and then the tangent is root 3 over 3. So for the 45, 45, 90, again, if I go back and look at what we were talking about just previously, and go back and look at the 45, 45, 90, this side was root 2 over 2, this side was root 2 over 2. So if I can make this a point, that would be here. That point would be xy, or root 2 over 2, root 2 over 2, and the tangent value is 1, because if I divide y over x, I get 1. So that's why you see me putting these in here. So what happens is that these values are given from the things that we calculated earlier. So that's just an important thing to remember when we look at that, because sometimes it just gets lost in translation because of just the amount of things that we're doing at one time. All right, so the last one we have to look at is the 60-degree angle. And so the 60-degree triangle or angle is given by taking the 30-degree triangle and upending it like this. And so if we go back and look at that calculation right here, that calculation is showing us that y is root 3 over 2 and x is 1/2. It's just reversed from this one. And the tangent, if you remember, was a little easier to calculate because we ended up canceling the 2 out, not having a denominator. So again, if we look at this right here, 60 degrees converts to root pi over 3. We have a point at 1/2 because the y mapping is a half and the x mapping is root 3 over 2. You can see that it's smaller, which makes sense because it's actually the same as this one over here. And then the tangent is root 3.